head now, except it's no alert left behind. And if you haven't seen Trolls, there's 3 or 4 of them now. They're entertaining. How many people have seen Trolls here? Okay, yeah, there's not a lot of hands up there. Watch it on the plane home. You good to go? All right, man. I'll let you introduce, give your background, but look forward to it.
All right, let's just make sure this works. Perfect. So hi, everybody. My name's Yotam. I'm Director of Incident Response at GEM. Before that, I spent the last 6 years doing incident response at Signia. And before that, I was in the Israeli military doing other cyber-related jobs. I'm not going to talk too much today about the job that I do, but rather about a very specific element of it, which, as Rick said before, has to do with the usage of threat intelligence in the cloud. So at GEM, we're focused on securing cloud environments, and we use a lot of threat intelligence to secure these environments and to get to the right kinds of detections and preventions within environments. And when we look at cloud environments, the reason that I even see this as an interesting and separate topic is because on paper, cloud environments should be the ideal ground for using cyber threat intelligence, right? These environments are very similar. They share a lot of commonality between them. Plus, attackers are using a lot of automations. They're using a lot of the same attacks and leveraging scanning in order to target cloud environments. So you would think that having some IOCs collected and shared would be a very straightforward application. In this case, and that's in many cases true, the potential value proposition for threat intel in the cloud is dramatic. And that's augmented by the fact that these environments are usually newer than the classic on-prem environment. So we need to rely on this kind of information. So where does this get more problematic? Well, I have one example which I think can show this. So what I just put up on screen, we don't have to read the whole thing. I know it's a bit small, is a real page with indicators of compromise from CISA. So CISA, a great agency trying to help all of us out with getting good CTI. And this, I think this little page outlines some of the challenge that we can see with many kinds of CTI, but it gets highlighted here. The first kind of IOC that we have here is this. So we have a very specific string, which is used to identify this specific malware used to target cloud environments, used to operate this specific campaign. Now, this kind of IOC is great, obviously. Like if it's a good identifier, we want to be on the lookout for it. But it's also way too specific, right? There's nothing preventing an attacker from just changing this string. It's not like this string is a specific vulnerability or something they have to use. They can just put in something else. So these kinds of IOCs, which are very, very specific, are nice. But because things in the cloud move very fast and very automated, in many cases, they're going to be out of date by the time that they're published. So that's one kind of IOC. The other kind is what we're seeing on the bottom of this page. So in this case, these are indications of the kinds of requests, mostly post requests, done by this specific malware against cloud environments in order to perform malicious activities at a later stage. But if we look at these actual pages, there's nothing unique about them, right? These are legitimate pages that you're going to have on most sites that run PHP. And therefore, as an IOC, they're difficult to use. And that gets into the second and much larger category of IOCs in the cloud, which are IOCs that are great. They are correctly identifying some activity performed by an attacker, but are also just super noisy. And because they're super noisy, we get alert fatigue, we get SOCs unable to see the forest for the trees, because for every one true positives, there's 100 false positives, and there's just no easy way to manage this. And unfortunately, we're seeing more and more organizations get lost in this noise, drowning in this noise. And then even if they have the right intelligence, they can't use it in time before the attack manifests itself to the very worst of its stages. So let me give you a real world example of what this could look like. I'm going to share an example now from a real incident that I responded to doing incident response. I'm not going to identify the specific client or the organization, so some of the details were modified, but everything that happened here truly happened to this organization. And I'm going to walk you quickly through the attack and then the way that it was investigated and where threat intelligence could and should have played a major role. So first, this organization happened to be targeted by an attacker, which found their way in to one of the employees' home environment as an initial compromise of the company. So this wasn't something that started through the corporate environment or through a cloud environment. This employee happened to click on a phishing link and get malware on their not personal device, on their personal work device, but in their home environment. Now, this device was compromised. That was not detected at the time. From this device compromise, attackers were able to move laterally into the corporate environment. So the company was using Citrix. It was enabling Citrix remote desktops to be used by employees leveraging this kind of access remotely from their home devices that were, by the way, managed by the company, just maybe not well enough to prevent this attack. And then once attackers were in this corporate environment, I'm skipping a lot of steps here. We're not going to detail every stage of the attack, but they were able to compromise a specific jump server, a specific machine within this environment that was utilized for managing sensitive credentials and access to the major cloud production environment. So most of this company's operations were in the cloud, and this is the way they were meant to access it. So ideally, on paper, this sounds like a pretty good security operation. Instead of just enabling access from anywhere to these sensitive credentials and sensitive privileged access to the cloud, they were only allowed from this jump server. However, once this was compromised by attackers, they were able to run very highly privileged API calls with credentials they got from the server directly on the company's production AWS environment. And they already have very privileged credentials because that's what they were able to compromise on the server. From there, again, I'm not going to detail every step of the attack, but the main things attackers targeted here were RDS databases, S3 buckets, and EC2 instances. So compute resources, databases, and storage buckets. And this was a purely data theft focused attack. So attackers were stealing data out of this environment, and they were doing it for a while. So because there was no immediate disruptive function, they weren't leaking this data, they weren't asking for a ransom, the company didn't detect this in time and then didn't detect this for a while until they figured out that something was wrong based on an alert that, frankly, the attackers could have avoided if they did their job a little bit better. But all of these phases of the attack, the reason that I walk you through them, not because the attack in itself is the most interesting, but because what's interesting is what we're going to talk about now, which is how the investigation into this attack unfolded, and more importantly, how it could and should have leveraged cyber threat intelligence in the cloud. So from an investigative perspective, going back to the same attack that I just showed you, from an investigative perspective, they knew none of this until they had initial indications that something was wrong with some of their EC2 instances. So attackers got a little bit greedy. They ran some commands that they shouldn't have on EC2 instances, and this triggered an internal initial triage process for maybe something's wrong here. It made them realize within the organization that it looks like this wasn't created by any of our people, any of our DevOps, so it must be something malicious. And that's when we were called in to start the investigation. And the investigation slowly revealed different parts of this attack. So from the EC2 instances, we were able to identify the wider access to AWS and the malicious commands run against AWS API. And from there, also the access I mentioned before to other resources. So the attacker went for databases, S3 buckets, and EC2 instances pretty much in parallel, but the investigation didn't know that. So the investigation happened to start from EC2 and then identify these other things. Only once all of this was going on, once the investigation was in this phase already, were we able to start leveraging public threat intelligence to cross-reference what we knew about these attackers. And there was information out there about these attackers with what's going on here. And the main way at this stage that we were able to leverage that kind of threat intelligence was the source IP addresses used by the attacker. They were not always the same, but they were always from the same VPN subnet, and they were a repetitive pattern. So that was connected to these attackers and made sense. Second, the way attackers moved between the different resources in this environment, again, I'm not going to get into every specific TTP, but the way that they were performing this was aligned with what we were seeing in threat intelligence. So it made sense within the investigation. Now, once this information was obtained, there was still a big question, of course, in the investigation, which is how did attackers get to this cloud environment, right? Because y'all already know the answer because I showed you the attack first. But at this point, the organization had no idea and no reason to suspect that their corporate environment was actually compromised first. Now, I'm not going to get into their whole security visibility and what they had and didn't have in their SIM, but doing this kind of correlation was not necessarily easy. Their jump server was using the same credentials from the same IP address, the jump server IP address, all the time to run API commands against AWS. So identifying that the attacker's initial commands getting this access came from that jump server and differentiating them from legitimate commands is not an easy task here. However, thanks to the existence of this additional information from the threat intel engines, what we could do is cross-reference this with the known subnets that the attacker was operating from. And we could see that when we cross-reference that with information gathered in the on-prem corporate SIM, which did have a lot of information about on-prem communication from firewalls and from other tools that they had on-prem, that enabled us to identify this jump server, how the jump server was communicating outwards to the same section of IP addresses used by the attacker to target the cloud environment. So not the same IP address, but IP addresses correlated to attacker servers that were being used from that environment were then correlated to other servers used by the attacker to target the on-prem environment. I'm not going to jump too much into that, but just to clarify what I mean here. So again, not the same exact IP addresses, but attackers did operate in a particular way from these servers. Specifically, they always had certain unique characteristics in their HTTP certificates on these servers. So by looking at the servers that were targeting the AWS environment and running them through threat intel engines, we were able to find additional servers which had the same certificates applied to them. Then finding these other servers which had the same certificates enabled us to find the communication to the on-prem environment. So without this threat intelligence, it would have been very hard to make the connection between the initial compromise of the corporate environment, which led to the compromise of the cloud environment, and the actual impact on production in the cloud. Now, once this was identified, when the jump server was known to be compromised, it wasn't that complicated to perform standard on-prem forensics and figure out where the connections were coming from. They were coming from a Citrix virtual machine. Again, there are challenges in investigating this because these machines are ephemeral and it wasn't there anymore, but Citrix does have logs, and we were able to tie it back to this initial machine in the home environment of the employee to be able to tell you the whole story, which I told you before from the attacker's perspective. Now, one last key point on this is that once we got to that home environment, once we knew that's where the attack started, we investigated the machine and we found out something more, which we could have known if we had the right information to begin with, which is that that machine too could have been identified through the same sort of threat intelligence. So I mentioned servers with specific unique kinds of certificates were communicating with the cloud environment and with the corporate environment. The same applied to the home environment, because this is just the way these attackers ran their C2 and their communications. So in this case, the investigation itself leveraged threat intelligence retroactively, right? We were there to figure out what happened after a lot of the damage had already been done. But now we can look at this picture, and something is wrong here, because this should not have been a retroactive investigation. If all of this information, if every stage of the attack was there in the threat intelligence, and by the way, these weren't necessarily new threat intelligence resources. These were things being used by the company, which had a pretty robust threat intelligence organization within the company. But none of this was identified ahead of time. Now, there are different reasons for why different things were missed here, but generally speaking, the problem was noise. Noise was a big issue here because there were communications going out to a lot of IP addresses from machines within the corporate environment. Why wasn't this IP address detected even though it came from a server which had the right kind of certificate, which should have been identified as belonging to this attack group? Because there were hundreds of very low severity alerts about communication to different IP addresses from this environment. The same thing happened with communication from the cloud environment. The home environment wasn't covered at all. Nobody was looking at logs for network communications from this environment. It was a home. There was no robust transferring of logs from the endpoint management that they did have to the SIM. So that cross-referencing was just not there. So what we're seeing here is there's a lot of very useful information. It was useful in the investigation and figuring out what happened, but it should have been more useful. It should have been there to help prevent or at least detect at a much earlier stage a lot of this attack. And that's what brings me to this thing that we call the zero noise approach. Because for years, we've been thinking about how we can approach this problem, that the cloud has just way too much information, and it's very hard to figure out what's right and what's wrong and what's to save and what's a false positive. And this is the general approach that we developed. Now, to be clear, zero noise doesn't actually mean there is zero noise. Okay, we're not naive. What we mean when we say the zero noise approach is that instead of just accepting noise as a God-given truth that we can't avoid, there are methodologies and approaches to detection and alerting in the cloud, which enable us to strive towards zero noise. Okay, so if our goal remains actual zero, not something that we say, okay, there's going to be noise, let's just live with it, but our goal is zero. We know we're never actually going to be at zero, but if we're close enough, we're at a point where alert fatigue and missing things because of this noise is no longer such a big problem. So let me walk you through the main elements of this approach, of what we mean and what we were doing with organizations to implement this. So number one is taking an attacker's perspective to threat intelligence alerting. So what I mean by this is, and we'll touch on this a little bit more in a second, but there are various kinds of ways to approach threat intelligence and the way that it's integrated into alerting in systems. But there is an inherent problem with just sitting, looking at incoming threat intel feeds and saying, okay, everything that's coming in is now becoming an alert. And the problem is not necessarily that the quality of the information isn't good. Maybe your feed is fantastic and it's all great. The problem is that it's not tailored to your environment. And once it's not tailored to your environment, the likelihood of creating false positives and unnecessary noise grows exponentially. Now, the different approach would be to take an attacker's perspective to your own environment. And of course, leveraging red teaming periodically is a great way to do that, but you can also just do this as a thought experiment. And think, in our specific environment, what are the most likely things an attacker is to do? Where are they going to target? How are they going to do it? Which systems are most vulnerable? And then to pick and choose the right threat intelligence alerts that are only applicable to these areas. That's going to dramatically diminish the amount of noise that we get, because a lot of things that are just irrelevant to our environment aren't going to be in there. It doesn't mean everything we put in there is going to be 100% correct, but it's going to be a lot more manageable. And what we find is going to be a lot more relevant. So taking this attacker's view of the environment first, and then determining what kind of TI we should use is very effective. That's number one. Number two is to implement continuous feedback loops. And this should be obvious, but unfortunately, especially in cloud environments, this almost never happens. So once alerts are implemented or specific TI feeds are implemented and put into alerts, what happens in a lot of organizations is they're just in there and that's it. An alert could be not triggered for 2 years and we don't care. An alert could be triggering every day and the stock just says, yeah, we know that alert triggers every day. Let's just ignore it because we know that it's never interesting. And they keep it in there the same way. Now, that is obviously not a way to get to zero noise. And it's obviously not a way to be sure whether what we're seeing in the environment is effective or not. So continuous feedback loops means that as part of the security operations regular methodology, there need to be monthly or quarterly or annually, whatever it is, processes for revisiting all the alerts that we have in the system, or all the groups of alerts, or all the feeds, and identifying them based on real statistics of how many times each alert was triggered, how many of those were false positives, what's going on here, creating an actual process for reviewing the quality of alerting within the organization and for each different TI feed that we're using, and then leveraging that information to address the alerts, either removing them, improving them, doing whatever is necessary with the alerts themselves. And that leads me to the third and most important point of this approach, which is no alert should be left behind. This is a key point. And this really happens too much. With almost every organization, especially in the cloud, we see this happening. We see specific alerts that are acknowledged as, oh, that's the noisy one. Okay, let's just ignore it. It just got triggered again. Or others that are just never triggered or never used, or even entire TI feeds which are ignored because, okay, it's going to be too noisy or it's never going to be used. And this is really a problematic approach. So what I suggest instead as a methodological approach is within this no alert left behind framework to approach every triggered alert as a decision tree which has to end in one of the following ways. So option one, of course, would be if we get a true malicious activity, if it's a true positive alert, then okay, the triage part is over, right? We're now doing a full investigation, escalating to incident response, remediating, doing what we need to do. That could be the end of the story for the alert. Of course, that's not the end for the organization. It could just be the beginning. But for the alert itself, it's done its job and we're happy with it. However, when we do get to this other side, when we get to a false positive, that's where things become more interesting. And what I'm trying to say here is that we shouldn't just leave it there. When we get to the false positive side, that should also trigger its own investigation. It's not a wide investigation. It's not full-on incident response, but we should have an immediate procedure for the SOC to investigate why this alert was triggered and why we treated it as a false positive. And ideally, of course, there are potential exceptions, but ideally, we should always arrive at one of three conclusions. One is, this is just not a good alert. And that's valid. Sometimes you will find that you have things in your environment, especially with TI feeds coming in from the outside and generating alerts, that could just be not effective for your environment. Maybe something's going on that in your environment is very common. So you just got to get rid of it. Maybe this is something that continuously triggers for scanning on the internet that doesn't approach any real data on your part or anything that you really care about. That's valid. And we could get to a conclusion that means this alert needs to go. And then there should be a process to review this. Of course, we don't just get rid of it right away, but that's one possible outcome of a false positive, just getting rid of that alert because it's not good and it's causing noise. The second option is to improve the logic. And this is where tailoring alerts to your environment and taking the attacker's perspective, what I mentioned before, becomes more important. So we can say, okay, this alert is not inherently bad, but we just came up with these three exceptions, these cases in which we never want it to be triggered. Or better logic for how to do the heuristics within an alert. Or maybe we want this alert to only be triggered if it correlates with 2 or 3 different TI feeds and not just one, because we want a higher level of fidelity. There could be different things that we do, but that's a second option. We could either get rid of the alert or improve the alert. A third option, which isn't as common, but it's very effective when it's relevant, is to change specific organizational practices. So as an example, there may be a case, and this happens with a lot of organizations, that alerts that create a lot of noise because something that attackers often do is also done by IT or DevOps or developers or somebody else in the organization on a regular basis. Now, if this is something that they need to do for their jobs, you can't just tell them to stop, of course, and then you need to come up with probably one of the first 2 solutions, either get rid of it or improve it, the alert, to get to a point where you're not going to trigger all these false positives. But there are cases where it's very possible to just change an internal behavior which is causing all of these alerts. So for example, it's very common in organizations to use a lot of different management tools. Why? Because there's a large IT organization, different people like different things. So you have one guy using TeamViewer and another guy using PSExec and a third guy using something else. And you have 6 different tools being used. And let's say one of these is currently being used by a massive campaign attacking your industry, and your TI feeds are saying you got to alert for any usage of this tool. It's very possible that just telling the IT team, listen, could you stop using this tool because we see you have 6 other tools, is going to work. They might say, sure, we don't care. We have other tools. And then that could be a great way of making the alert better by changing internal practices. So like I said, this isn't the more common case, but it is a very effective one when it could be applied. So this kind of decision tree, following this kind of procedure when approaching alerts, especially in the cloud, is a very effective way of getting to this, what we call zero noise approach. Again, not actual zero, but we're no longer drowning in noise. Now, to put this all together, I want to give you another real world example of an organization at which I performed an incident response. We saw a very large attack, but then we also helped create this kind of process to improve and fight this problem. So very quickly about this organization, this is a financial organization. They had different aspects that were creating different financial transactions, but at a very high level, what was going on is this. Attackers were continuously accessing servers that were in their DMZ, web-facing servers, which for many different reasons, they kept having either unpatched things or things that are left open to the internet. They had recurring problems in these servers over years. So attackers would come in again and again and again after being kicked out again and again and again. Now, after accessing these servers in the DMZ, attackers would then move laterally. There were connections. Again, I'm not going to get into every detail, but move laterally to what they call their internal servers, so servers that weren't directly connected to the internet, but they were connected to the DMZ to enable this communication, basically to enable data to flow from the internal network to the DMZ when it was necessary. And then from there, they would move to targeting points of sale. So I'm not going to explain exactly the whole procedure of how this works, but this company had many different kinds of points of sale. Some were like ATMs, some were different points of sale, but they all had to do with financial operations. And when attackers were able to get to these points of sale, they would then create transaction requests to load balancers that were stored in this environment, which would then, and another thing attackers did was jump directly to the load balancers as well. So what would happen here is every time attackers would successfully transfer funds outside of this organization, they would do this for a month or two. Eventually, they'd be caught, usually through accounting controls, not cybersecurity controls, and then trigger a cybersecurity investigation. They would be kicked out by the internal cybersecurity organization, but very quickly they would come back in and do it in a different way. So sometimes they would go this way, sometimes they would go this way. Every time they had a different way of approaching the place where they can create transactions, but the end result was always the same. Load balancer would get transaction requests which appear legitimate, and then send that over to the servers that actually manage the financial transactions. This could be Swift, it could be cryptocurrency transactions. They had different things, but money would go out the door. So this attack kept repeating itself again and again for years for this organization in different formats, every time a different entry point, every time slightly different lateral movement, but it doesn't matter. This kept going for years, and this is a very well-known group that performed these similar attacks against many other organizations within this field. So there was also a lot of threat intelligence around about these guys and new information from other companies that were being targeted. But again, we went back to the same problem. The company kept saying, yeah, when we incorporate this threat intelligence into our alerting, we can't get out of it. The SOC finishes yesterday's alerts today if they're lucky. So we're not really catching on to anything. And then we said, okay, we know this is what's going on. Let's take the approach that we discussed. Let's take this zero noise approach and see what we can do step by step. So number one, if we do this very basic thing that I mentioned, taking the attacker's perspective to this organization, then there's one thing which no matter where attackers are going to come from, right? It could be different spots in the DMZ, it could be different servers along the way, but in the end, these attackers are always interested in one thing, which is creating transactions. They are stealing funds. So maybe we can do a lot of good by first focusing on just that part of the environment. We don't care about everything else. Let's say the attackers will keep getting in, they will keep moving laterally, they will keep escalating privileges. Of course, we care about that stuff, but not right now. Right now, we're saying for the purposes of leveraging threat intelligence, let's first focus on these transaction creating servers, the ones that can actually move the funds, because those are the ones that attackers are always going to be, they're always going to have to target eventually. And in doing this, we're able to incorporate very specific threat intelligence that had to do with the way attackers were creating transactions. Now, again, I'm not going to get too specific into the details of the transactions, but this has a lot to do with the talk that we just heard about the importance of cooperation for obtaining this kind of threat intelligence, because similar financial organizations in these positions had very good live information about this. They're always doing this kind of transaction. It's always over this, but under this threshold. It's always access being performed at certain times of the day. It's always being transferred to certain kinds of accounts or others. And this information was very good threat intelligence that we could incorporate right away into these alerts without taking all the rest of the threat intel, which was creating too much noise. So this initial step already did a lot of work in expediting detection. Now, a second part here, that's why I like the stories, we have all the different parts, was figuring out that some parts of the threat intel alerts that we had in this environment were just no good for this company. So I mentioned that attackers would usually come in through these website servers in the DMZ. And the problem was the way attackers were doing this, it kept changing. It kept changing every time. But there were just, this is a large financial institution, and the operations attackers were performing looked initially a whole lot like scanning. Everything they did before successful access to the company really looked like scanning, and eventually they were always able to find some vulnerability or some misconfiguration which let them in, which of course is a separate problem which needed to be addressed. But on the alerting side, the fact that all relevant alerts were just continuously being triggered because everybody is scanning the internet all the time and there were 1 million hits a day, at this point was a good enough conclusion for us to come and say, hey, listen, let's just get rid of these alerts. These alerts that can be triggered by any generic scan are just not good enough for this environment. You have a million servers facing the internet. All of them can be scanned in the same way, in a way that is potentially not doing any damage yet, right? Because there's no access yet. It's just scanning. Let's just get rid of this. And getting rid of that also went a long way in reducing the amount of noise and focusing in on the relevant alert. So that's number two. Number three, and this is an important point. If you recall, I mentioned before, one thing we can do is get rid of the alerts. The other thing we can do is improve existing logic. So the company did have certain alerting and certain visibility into the requests getting to this load balancer. The requests created by the attacker in order to create malicious transactions. The problem was that these were very hard to distinguish from legitimate transactions. They had many different kinds of customers, which would create legitimate requests for all kinds of transactions, some high, some low, some weird times, some not. It wasn't easy to necessarily identify these transactions. However, once the understanding was established that these alerts that they had based on different threat intelligence regarding how the attacker is creating transactions at this stage were too wide, they were creating too much noise, what we figured out is that for this specific organization, they could be improved dramatically. I'm not going to get into every part of the detail, but part of what the threat intelligence about this attack group told us is that the way they operate when they create malicious financial transactions is they usually create them behind the scenes. They create them back at their command and control servers, and then send the fully made transaction through whatever access they have into the organization to where it needs to go. Now, in this specific organization, they had different levels of visibility at different places, but when a transaction was created legitimately at a point of sale, it would also include a timestamp for the transaction for when it was created. Now, the attacker's transactions also had to include a timestamp, otherwise they wouldn't be accepted. But that timestamp, because they would usually have to go through a bunch of different steps in order to get to the load balancer, instead of going straight from a point of sale, these timestamps created by the attackers were usually backdated much longer. And these weren't hours or days. These were differences of seconds. But a standard transaction from a point of sale would usually have less than 1 second of a difference between when it actually got to this load balancer and when its timestamp said it was created. However, the attacker's transactions, and we knew this thanks to threat intelligence, right? We had the ability to look and understand how these attackers operate across the board against many different organizations. They were always backdated because they were created much earlier. So establishing specific alerts, looking at this, comparing the timestamps, the one that's within the transaction and when we actually got the transaction, and cross-referencing that with the rest of the information that we had about just the generic alerts and the tailored alerts the organization had for detecting malicious activity was very valuable for identifying when attempted theft was occurring. Final point here was the access to these, what I called before, the internal servers. The management of these servers within the organization was kind of a mess. And this has to do with the example I gave before about different ways of managing access in the organization. So people were managing these servers in different ways. This was a cloud environment. They were using SSH to access some of these servers. Some of them were Windows servers. They were using many different tools over SMB to access these servers. Some were using RDP. They were also using native cloud tools to manage these servers like AWS SSM. And attackers would usually repeat the usage of one thing. It would almost always be SSH connections within the network. Now, in this case, because SSH connections weren't necessary for the organization, they already had a lot of other ways of managing these servers that were in place, we were able to come up with a very simple solution. We knew from all over the world, threat intelligence is coming in. These guys are always using SSH. You guys don't have to use SSH, and you're facing these same attackers again and again. Just don't. Just start using something else. And this wasn't such a big problem and such a big transition because they were already using other things. It was just about stopping to use this one thing, and that made this alert a lot more effective. So the reason I like this example is because you can see how all the different things you're taking the attacker's perspective, getting rid of some alerts, improving other alerts, and just stopping certain organizational practices go a long way in ensuring that we're actually getting to this zero noise. So with that, I'll end the lecture part, and I'm happy to take any questions.
One observation that I had as you were going through the tuning, it's a good opportunity for the Intel analysts to work with the detection engineers in your organization or the detection engineering team in a managed detection and response provider it's out there, because really you're tuning these alerts to make them higher fidelity. A number of questions that had come in. Well, let me go to the room first. Do we have any lightsabers in the back? Yeah, I see a green.
Yeah, I see green, but
How you doing, sir?
Yeah.
It's me.
yeah,
Okay, yeah, yeah.
hard to
well,
see, but I got you.
See, you're right below the two
Yeah,
lights.
Yeah. I need to stand up. I stand up. I appreciate what you said about investigating false positives. I don't do that, and that's something I'm gonna incorporate from now on. But can we have access to your slide presentation or no?
Sure. Yeah, I think it's given.
Yeah, if you're comfortable sharing, then
Yeah,
it'll
of
be
course.
available.
But by the way, that's something that like there's no shame in that. That's a very common practice, especially in cloud environments. There's just so much noise. Initially, investigating every false positive is very difficult. But once that process gets started, there's just less and less false positives. So you need a mandate to do that from whoever's managing the team, because initially it's going to take up more time. But as time progresses, it's going to be more effective.
There was a question in here, and then we'll get to Gert-Jan, around trying to justify, the work required to do the tuning. I mean, if you take an alert and then you add up the time that the team, the SOC level 1 analyst, maybe if it gets handed off to higher level people, spend on it, you could say, hey, we get this alert 20 times a month, and it's taking our analyst 2 hours per full life cycle. You could add up the time and say, hey, look, time savings to the organization. Let's put the time in to tune these alerts, or to kill the alert, to really make it zero alert, right? Get rid of it altogether. So just a suggestion there. But Gert-Jan had a question.
So I want to add on what you were saying, Rick. I think I love the idea, no alert left behind. I think from my experience, I often see that teams do not get through like the 3-tiered actions following out of the investigation, right? Close up shop, work together, move on, and then you're left, working on yesterday's issues and moving on. So what would you, in addition to what you already mentioned, say to teams, trying to solve that issue? How can they prioritize certain discussions? Any final thoughts or considerations on that? Because I do see a lot of teams struggle with that.
Yeah, I think that has to do with the comment before that it is going to be more work initially, and it's hard to get yourself to do it, right? Because at the moment, once you figured out something is a false positive, you just want to move on. Why waste more of your time? But once, and I think any analyst that's been in the job for more than a month could agree with this, once you see that this is not a one-time thing, that this repeats itself again and again and again, you have to come to the understanding that you're actually wasting more time by not getting to the root of the problem. And an important point to this is you need a mandate to do this, because your manager needs to understand that if you're getting to the root of the problems now, then you're going to take longer to move on to the next thing. And you need the resources to do that. But it's in everyone's interest to invest that time initially, because the gains later are dramatic.
I see a lightsaber in the back.
Yeah.
Thank you for the presentation. It was great. I know a challenge for a lot of organizations is having a multi-cloud environment. Can you speak to some of the solutions you've found in terms of reducing noise when you have a lot of cloud environments with different alerts that might overlap? Thank you.
Yeah, that's a great question. That's actually a lot of the focus of when we're creating our own tailored alerts. It's a lot of the focus is on multi-cloud, because that's where a lot of the challenge is. I think there are two parts to this. So one part is, the approach should be ideally the same. Even if you have more, maybe you just need more people or more time to do it, but you need to try for each environment, the stuff that's separate, to treat it the same way. But the second more interesting part, I think, is that in multi-cloud environments, often the problem is that the risk is slightly different. The risk becomes, what if somebody moves between my cloud environments rather than targets each one of them separately? Or like the example we saw here, from on-prem to the cloud in this hybrid attack. And then that's where tailored alerting becomes critical. So there's an issue with just having generic, this is a cloud environment, here's an alert for a cloud environment, when you have this multi-cloud architecture. However, if you have alerts that are tailored to this, so we build a lot of alerts that are based on common lateral movement techniques from Azure to AWS, or from AWS to GCP. And when you have those that are very specific, you actually get a lot less noise on them, because it's unlikely you're going to see a lot of legitimate activity performing this kind of lateral movement.
I think with that, we'll go ahead and wrap up and then bring Andy. up to the stage, but thank you very much. And there's still a number of questions in Slack if you want to take a look at that.
Sure. Thank you.
Oh, somebody else is setting up a laptop. Should I do more trolls jokes? As Andy's getting set